Hey everyone, I'm Matt and welcome to just out in front of my shop. Well, today I've got just a little bit of a different project than I normally work on. This isn't automotive or motorcycles or anything like that. This is a drywall texture spray trailer. Now I know I've mentioned it before, my normal kind of 9 to 5 sort of job is doing timber inventory in the woods with drones. I'm also the fire chief on my local fire department, but I also make my living fixing stuff. Random things, typically things that other people can't fix, or there's a tight deadline on, or there's some kind of difficulty in getting it fixed. That kind of stuff sort of just finds its way into my shop, and that's what's going on here. This is owned by a friend of mine who's got a local drywall business. Now there is a shop, I think it's up in Seattle, that he normally uses to work on these, but he's got a job coming up here in a couple of weeks that he needs this trailer for. And the shop said they were at least a couple of months out before they could look at it. So it found its way here. Now, I don't know anything about drywall spray trailers, nothing at all. But this is a pretty simple system. I'm just gonna take a few minutes, take a look at it, and figure out how things work. And then we'll drag it over in front of the shop and see how things shape up. I do this at the kind of the beginning of each project that I start, where I don't really know how the equipment works. This is a big hopper right here. It's got this agitator in it. These right here are hydraulic speed control valves. One of these controls the hydraulic motor for the agitator, and the other one controls this hydraulic motor down here. And that's a positive displacement pump in there. I don't really know what's in there, but that actually pumps the material through this big hose and out this nozzle right here. That's something I think I'm gonna have to be careful about, because it doesn't look like there's any kind of pressure relief in there. I'd imagine that if I have the valve closed and I turn that on, I could cause damage to the pump or the hose. So I'm just gonna leave the valve open with it in the hopper, so I don't forget that. I definitely don't want to break this thing. The engine's just your standard little Kohler V-twin here. It's got a belt drive compressor. The compressor's air tank is the frame on the trailer. And it also runs a hydraulic pump right here, and that's what controls all this stuff. Now this right here is a diverter valve, and this is what turns on and off the hydraulic flow to the material delivery motor / pump assembly down there at the bottom. So pretty simple. What the owner tells me is that when he tries to turn on and off the material delivery pump, it doesn't always turn on. Sometimes it does. And then he said the last time he used it, it stuck on for a while. I'm kind of starting from scratch here. I haven't looked at this at all. I don't know what's wrong with it. So I think I'm gonna drag this over in front of the shop, fire it up, warm the engine up a little bit, and just see if I can duplicate the problem that he described. Okay, I think I'll turn these to 0 just in case. Open this thing up. I guess we gotta throw it on battery charger here in order to get started. Well, some time has passed. Let's see if we can try this thing again here. All right. This is material control and agitation. Let's just see what we get here. So the way this thing works, it looks like there's a little valve right here that sends air back to a pneumatic actuator that turns on a switch that operates the diverter valve. So when I go like this with this collar, it sends air down to this switch right here. It should turn on that pump. See what happens. Well, I heard the compressor kick on, but no load on the hydraulics. When that button's pressed, it should be operating the diverter valve, which should be turning on hydraulic flow to that delivery pump. That's not happening. So I guess the next step is we'll see if we're sending voltage to that solenoid. These are some of my most useful electrical troubleshooting tools. These are wire piercing probes, and basically you just hook these over the wire and then tighten down on the end, and a little tiny needle comes out and pierces the wire jacket. Not always the best thing because you are leaving a pierced wire insulation, but it's such a small hole, generally it doesn't actually hurt anything. So what I'm going to do is just attach these down here on this diverter valve, and then we'll hook a voltmeter up to it and see if we're actually getting voltage to this when the switch is depressed. Well, I got distracted by the good weather today and went up to the airport and took my airplane out flying. So anyway, we're back here in the dark now. All right, this reads 0 volts. Now, I actually don't really know where this thing gets its power from. I just assume the battery. So I'm just going to depress the switch down here, and if everything's working the way it should, that voltmeter should read 12 volts. And it's not, but I don't really know where it's getting its power from. If we look at our yellow wires coming out of here, one of them goes to that switch that direction, the other one comes here, and this is it right here. Goes back here. This must be it right here. And that goes to something inside the engine. That must be like a 12 volts from the built-in alternator in the engine. I think what I'll do is I'll unplug it and jumper it to the battery just so we can do some testing. Alright, I've got this jumper here. Alright, now that's going directly to the positive terminal of the battery. So now when I depress this switch, I'll see what we get. Where is that thing? So I think I'm going to start this up and see if, now that I've got that jumpered, when I depress that button, if that pump starts working. Okay, in case you didn't quite get what we were doing there, I jumpered to the battery for that diverter valve and then depressed the switch manually, and we're getting 12 volts sent to the diverter valve. It's just not diverting. So something's up with that valve. Maybe the solenoid's bad. Maybe the valve is stuck inside of there. I don't really know, but I think I'll test the continuity of the solenoid. If that's good, then we're just going to have to take that valve apart and see what's going on with it. All right, that solenoid is 5.7 ohms. So that solenoid is good, or at least it has continuity. So I'd say it's time for us to take that valve apart, see what's going on. I decided to pull this thing into the shop so I could keep the hydraulic system clean, hopefully limit how much I spill on the ground here. Oh, interesting. There's a big crack on this solenoid. I did not notice that. Oh, if that clears, it does. Look at that. Clear it? Oh, it does. Nice. Well, I see the Delta Power logo here and this number 2336. And then the solenoid, the coil here. It also says Delta Power. It's like DDL12 and it says 12 volts DC. Now, when I look at this, I can see there's a split right here with some green stuff coming out of it. It's also split right here. And then more green stuff here. There's two separate splits there. Even though the coil had continuity, I highly suspect that many of the windings in there are shorted together, and so it's actually probably drawing more current than it should with reduced magnetic pull. And so I'm sure that what needs to happen is this coil needs to be replaced. I'm going to take it off and just make sure that the valve moves freely. If it does, then we'll see if we can locate a coil. Do some gentle agitation here. If it's moving or not. There we go. Well, the new solenoid showed up in the mail today. I put it on the cartridge right here, and when I hook up 12 volts to it, there's visual movement that I can see with the valve inside of here and an audible click. So I know that this new solenoid is working. I am reasonably certain that this is going to solve all of our problems. Like I said, this old one right here, you can see these splits and cracks in it. It's still, you know, it measures out at 4 ohms. I put the ohm meter on the new one, it's about 6 ohms. So I think that what's happened is a good portion of the coils have shorted out inside of this old solenoid, and that has reduced its ability to exert magnetic force over the poppet valve inside of here. And yeah. So I don't see any reason to try and disassemble anything any further. I've cleaned everything up, and I think we're ready to throw it back in the machine. Now, I could have probably done this with the whole valve left in the machine, but as you saw, I had a hard time getting the coil off of here. This just makes things way easier. Look at that. Now only one piece of this T has thread sealant on it, and the reason is only one set of threads are tapered pipe threads. So those tapered threads require thread sealant. The other fittings don't. All right, let's fire this thing up and see if she works. Drywall splatters all over the place in here, so I'm going to shut this thing down. All right, looks perfect. I won't run it too long inside the shop here so I don't give myself some carbon monoxide poisoning, but yeah, looks like it. We found the problem. We replaced it with a new part. Trailer works great now. I wish all projects were this easy. So thanks for following along, guys. Appreciate it, and we'll catch you on the next video.